talk about experimenting. We're supposed to go over this last Friday, but of course I wasn't here. So I want to make sure that we have a good idea what experimenting is. What do you think experimenting is? Yes. Yeah.
Like doing a test.
Okay. What are we testing?
Like your idea.
Okay. Experiment does test one thing in particular. What was it?
Hypothesis?
Yeah. It tests your hypothesis.
Yeah.
So that's the only time we ever do an experiment is when we're testing a hypothesis. If you don't have a hypothesis while you're doing it, then what are you doing?
Nothing.
Just have fun, right? Blowing things up, whatever. Okay. So we're going to go through this, and I'm going to go through the notes that we did before, but I've done just a little different. I'm hoping that this will be a little bit better as we move on. I worked on this yesterday, and we'll see how it progresses, and eventually I'll have it up on my channel here. But so let's take a look at this. Okay, so you should have this out in front of you. Okay, so we're going to take a look at this and see what exactly we need to do. We're going to do an experiment on plants. Okay, so we decided we want to do an experiment on plants. There's a few things that we probably need to know about the plants. Hey, get old Einstein up there. What do we want to do? We need to know, what does the plant need to live? Okay, that's pretty critical. We need to know what the plant needs to live. So, what does the plant need? Okay, we gotta have sun.
Soil.
Soil.
Water.
Water. There's 3.
Air.
Air. 4. 2 more. Okay, we gotta have food, nutrients. Okay, 1 more. This one is always the hardest one for people to understand. What is it? Temperature. Yeah. So last night I went out and I covered up all my tomatoes because last night it got really cold. Noticed the drop in the temperature yesterday. It was kind of nice. It was like, oh yeah, kind of cooled things down. Put out some of the fires that we've got going on. So I went ahead and covered them up because it's supposed to get cold enough that we were to get frost, and tomatoes are really susceptible to frost, and so I want to make sure that they get covered up so I don't damage the plants. So temperature plays a big role in how plants grow. In fact, tomato plants, if it's over 80 degrees, they won't produce any tomatoes. So it has to be under 80 degrees before they'll start producing tomatoes. So plants are very, very susceptible to temperature, and many of you probably already know that. So let's write these things down. These are the things that we said we would need. We need sun, water, food. Okay, we need the temperature to be just right. We also need the soil conditions to be right, and the air needs to be correct as well. And we don't want to be like, if we had plants, do we want to give them 100% oxygen to live off of?
No.
Yes.
Don't kill them.
No way, because plants hate oxygen. They try to get rid of it, and we try to gain it because we like it. They don't, but we try to get rid of what?
Carbon dioxide.
Carbon dioxide, and the plants love it. And that's what they want. That's where they get their food. It's how they grow. It's from that carbon dioxide. So, what do we call all of these things? We have the sun. We have.
Photosynthesis.
Nah, we're gonna give these a special name. Okay, what do we call these?
Elements.
Starts with a V.
Variables.
Variables. Good. What's a variable? Okay, and next can be a variable for sure. What else?
Is something that we don't know.
Say that again.
Is something that we don't know.
Okay, yeah. So here's the way I like to look at variables. If we took your table and we put a puzzle on it and all the pieces were all missing, right, it wasn't put together, they were just kind of scattered out everywhere, every little piece would be a variable. And when we put them all together, it makes the whole puzzle. So when we look at these things, these variables here, are there more variables than this? Yeah, there's a ton of them. When we put all the variables together, it puts what our flower or our plant needs to survive. Those are all the variables that we need. You can also think about it as like a recipe. So you have a recipe card, and all the ingredients are all the variables. When you put it all together, what do you get? I don't know, cookies, brownies, cake,
Brownies.
whatever, bread. So you put all those variables together. Okay, this is what we call the control group. And the control group, it's a good name for it because what does control actually mean?
You control.
Control, yeah, when you think of the word control, what do you think of? Control?
Controlling something.
Okay, then you have total power over it, right?
Yeah.
If you're going to control something, you have total power. So, in our control group, we're going to have total power over all these things. How much sunlight does it get? Oh, it's going to get 8 hours. How much water it gets? We'll give it 1 ounce a day. Food. Okay, we can control the fertilizer and the nutrients it gets. We can control the temperature. We can control all of these things. So, these have another name to them. They're called control variables. And the control variables are found in the control group. Now, you don't have to write down control variable on each one, but you should at least write it for the top one and then maybe put like CD or same, whatever. But these are all the control variables. So this is our first group. This is known as our control group. Now the control group, why do we need a control group? Any idea?
Why do we need it?
Yeah, why do we need a control group?
Because if we don't control it, it will go as well.
It will go up.
It will go wrong.
It could go wrong. Okay, not so much that it can go wrong. But let me give you an example. So, for the first of the year, when you first came in, I pull up my phone and I'm starting to look through the attendance, right? And I have to do this every beginning of class. And there's your picture. And I look at the picture and I look at you and I'm like, yep, they're here, yep, they're here, yep, they're here. But those pictures don't look anything like you. Why? It was last year's picture. Okay, that's what you looked like last year. Okay, 12 months have gone by. A lot of things have changed. Okay, maybe you got your braces off. Maybe you got your hair cut. Maybe you grew it out. I don't know. Maybe you started wearing makeup. I don't know. You know, maybe the braces came off. Maybe the braces came on. Maybe you got your ears pierced. Whatever. Maybe you grew 2 feet. But things have changed. Yes, sir.
What about the mask?
Yes, definitely the mask have changed too. Hopefully you didn't take your picture with your mask on though.
It wasn't allowed.
Yes. Okay, so there's a lot of changes, but how do you know that you changed?
Look in a mirror.
No, what do you compare it to? Last year's picture, okay? So your last year's picture is really the control. You're looking at last year's picture versus this year's picture, and when you look back, you're like, wow, I really changed. I don't do this anymore, I don't see this, I don't see that. So now tell me, why do we need a control group?
Do you remember what you looked like?
We want to see what the changes have occurred. So whatever happened, we look back at the control and look for the differences, and whatever differences we see, that's how we know what changes took place. Just like by me looking at your picture of last year versus right now, there's a lot of changes that have taken place. And next year, it will change even more. So that's why we have a control group, so that we can actually see the original and compare it to what we have now. So what about the experimental group? What goes in the experimental group? Yep. Okay, well, the experiment is what we're calling this, but what needs to go into the experimental group? If we're doing an experiment on the plant or a flower, what needs to be in the experimental group? We have the control group. What needs to be in the experiment group? There would be an independent variable, but before we even go there, what do we need? Think. What?
The object.
The object. Okay, what about the object? So we have a flower, right?
The hypothesis.
Well, no, not so much the hypothesis. Okay. Don't we need to have this? The sun?
Yeah.
Don't we need water? Do we need the same amount of food?
No.
Yeah, we do. The temperatures need to be the same. The soil needs to be the same. The air should be the same. In the experimental group, we have to have another flower, another plant in there. And we have to give that plant the exact same stuff as the control group. They need to be the same. So if I give 8 hours of sunlight to the control, I have to give 8 hours to the experimental. 1 ounce of water, 1 ounce of water. Everything needs to be the same. And some of you are like, oh, wait a second, waters, that doesn't quite make sense. It does. Everything has to be the same, and here's why. What do you think this group is called?
The experimental variable?
No, not experimental variable. It is a variable. These are all variables, but what are they?
Dependent.
Nope. So are the C. So I think a lot of people get confused with these two words. They seem the same, but they're not. Yeah.
Constant?
Constant. These are the constant variables in the experimental group. So we write these down as constant variables. And I'll explain why here in just a minute after we get this all written down. Now we are going to erase one of these, but for right now, we want to just impress on you that, hey, these are all the same. This is why they're called constant. If I have 8 hours of sunlight in the control, then I want it to stay constant in here too, 8 hours. If I have 1 ounce of water here, I want that to remain constant also. I want 1 ounce of water. So we call these constant variables because they didn't change. The control variable is the variable that remains the same, and it's easy to identify where it is because it's always in the control group. If I'm having a question, like on a test or anything like that, and it said something to the effect that the constant variable of water was changed to 23 ounces or something, I don't know. Just by knowing the word constant, what group are we talking about? What is it?
Experimental.
We're talking about the experimental group. We're not talking about the control, we're talking about the experimental group. So the minute you see that word constant, we're talking about this group, not this one. Which should help you to be able to identify some things. These will never change. But some of you said, hey, we need to make a change on that. Now that's true. Because right now, they're both identical. So when we do an experiment, we get together, we look at this stuff, and like, I think we need to make a change here. I want to test this flower. I want to test this out. So I think I'm going to get rid of the water. And instead of putting that nice, clear, good water in there, we're going to change it and put in blue water. Oh, yep. Good old blue water. So we put blue water in instead. Now, is blue water the same as this water here? Is it constant anymore?
No.
No. In fact, this is the only variable out of all of these variables that have done what?
Change.
Changed. And it's by itself. What do we call something when it's by itself?
Independent.
Independent. So now this is what?
Independent variable.
Very good. This is now the independent variable.
We don't need to erase one.
You at least ought to write this down in there. Okay? This now becomes the independent variable. The independent variable is on its own. Okay? It's not the same. So now we know, oh, these are constant variables, which means they're the same as the control variables, but they're in the experimental group. The independent variable is the one that we actually changed. So we decided we're going to give it blue water instead. So we go ahead, we do the experiment, we run it through, everything stays the same. In fact, this still even gets just 1 ounce of water, but it gets an ounce of blue water instead. The temperature of the water remains the same, everything's the same. Put it back through, we've only tested blue water. Why would we not test 2 of these?
Because it's a lot harder to control your experiment when you're trying to do 3 different experiments.
It's
at
really
once.
hard to control your experiment, okay? If you had 2 buttons and you didn't know what they were, and maybe there was a couple of lights out there, and you knew that the buttons will probably turn on the lights. You push one button, and what would happen? One of the lights might turn on. So you know what that button does. Push the other one, and you know what the button does. But then you push both of them, both lights turn on.
How do you know which
But
side
do you
to
know
push?
which button turns on which light?
No.
No. How would you ever find that out?
You'll push the button.
You just do one. You don't do two. A good mechanic will do this too. If you got a problem with your car and the mechanic starts testing some things and has an idea, oh, this is what's going on, but they see that there might be two possible things going in there, so instead of testing one at a time, they just take both parts out and replace them, and the car's fixed.
But it's twice as expensive.
It's twice as expensive now, and do they really know what the problem was?
No.
No, they don't. So it's better just to test one and fix it the first time. It'd be cheaper and more accurate. So we don't test more than one thing at a time. We only test one thing. We don't test more than one. And how many times should we do this test?
As many times as needed.
Minimum how many?
Five.
No, you can do
Twice.
less. Well, if I do one and I get one result and I do the other and I get another result, then how do I know which one is which?
You're gonna have to
Do one more.
You got to do one more. Because the third one was going to give you a little bit more better information. You're going to get a better average. 3 tries is the very, very, very minimum. Okay, you should do this 100 times. Okay, even thousands of times. You should do it as many times as you can to make sure that you can just narrow things down and actually get a definite answer of what's going on. So we do this many, many, many times. So we go ahead and we run the experiment. We run it for, I don't know, a month. We do the same thing over and over and over. And voila, the results. What do we get?
blue flower.
We get a blue flower. All of a sudden we get this nice blue flower. Like, whoa, we got a blue flower here. That's pretty cool. How did we get a blue flower?
Go to the blue.
We gave it blue water. See how simple that was? But what if I had 2 different variables? Be like, I don't know. Could have been this or this. I don't know. Now you have to do the test again. Right? Blue flower. What do we call the result of the experiment?
Blue flower.
No, we don't call it blue flower. You know that's the result. But what do we call it? It has a name, like independent, control variable, constant variable. This has a name also.
N variable?
No. And it's always directly linked to the independent variable. In fact, you can even find the word in independent. It's the dependent variable. Okay? So the blue flower, or the result, is the dependent variable. This is the dependent variable right here. How do you know dependent is in independent, and they're both linked together? Whatever the dependent is, you got to look for the independent to find the connection. That's the only thing we changed, and so it has to be a direct link in there.
Oh, okay.
Does that make sense?
No.
Okay, they have to be together because we didn't change anything else. So this one is always connected to this one. If you've got more things out here, then who knows? Okay, that's where things get a little confusing. Okay, how do you feel about experiments? You feel like you do okay on it?
Yeah.
You know the difference between constant and control?
Yeah.
For sure?
Yes.
Okay, where do you find the constant variable?
On the experimental.
In the experimental group. Where do you find the control variable?
And the control group.
Good. And that's not a hard one because it says control variable, so it should be in the control group. It's the only one that has a little bit of a different name to it. Awesome. Feel good about all that?
Yeah.